Hello, everybody. Thank you for joining me today. My name is Michael Franti, and I'm VP of Product Marketing at Portworx. Um, I'm here to discuss a topic that I think is on a lot of people's minds once they've gotten, say, 6 to 12 months into their Kubernetes journey. As you get comfortable with Kubernetes, as you start to run more and more applications on your Kubernetes platform, you inevitably start to run applications that require advanced data protection, backup, disaster recovery, and kind of everything in between. And it's not obvious how you solve those requirements on Kubernetes natively. And so what I'm going to talk about today is really twofold. One is, regardless of the data protection solution that you ultimately implement, what do you need to understand about how backup and disaster recovery are different for your Kubernetes environments than they are for your what I'll call your classical environments, and that could be your VMware environment on-prem or your kind of your cloud environments running in Amazon, Google, Azure, etc. Second, I want to talk about how the Portworx storage platform for Kubernetes provides a packaged solution for solving backup and disaster recovery for all of your applications running on Kubernetes. And we hope you give that a try. But even if you don't, you'll walk away from this webinar with a really clear understanding of what are the contours of the problem that you're going to need to solve to provide data protection on Kubernetes. So with that, let's dive in. Before I get into the details, I want to just give a little bit of background on myself and my company. You may not be familiar with Portworx. We make a storage platform for Kubernetes that's trusted in production by some of the largest and most sophisticated Kubernetes users worldwide. So everything that I'm going to share with you today is really drawn from the experience of working with companies like Comcast, like T-Mobile, like Ford, who are really running real applications on Kubernetes, real production environments, real business and compliance requirements that inform how they are architecting their applications and how they're solving classes of problems like data protection. Portworx, as a company, we do more than just data protection. And so as you can see, we do security for Kubernetes in terms of data security, persistent storage for Kubernetes, migration services for data-rich applications running on Kubernetes. But today we're gonna focus mainly on those data protection topics. The second thing that I'll share is that Portworx was recently rated the #1 Kubernetes storage platform by GigaOM Research. They did a kind of a large-scale analysis of the Kubernetes storage ecosystem in what they call the GigaOM Radar. It's their version of the Gartner Magic Quadrant or the Forrester Wave, and we're really proud to be positioned where we are. And again, this is really just to kind of assuage any of those concerns about where is this person coming from? Is this thing real? Is it just does it make sense in theory, but in practice I'm gonna struggle a lot. As practitioners, we understand that when new tools come out, it's kind of hard to separate what's real from what might be great in 2 to 3 years, but really isn't ready for prime time today. And these first couple of slides are really just to kind of establish that that knowledge and that expertise that you can bring back to your organization and you can implement in ways that make sense for your business. Okay, so if we can start by saying, backup and DR are, pretty much essential for enterprise applications. I don't think this is a controversial statement. And why exactly we have to implement backup and DR are going to be different for every organization. Some are really driven by classical data protection, right? I simply cannot afford to lose the data that's running in this particular environment. And data protection was one of the top reasons enterprises gave for implementing backup and disaster recovery in the 2019 container adoption survey. But there are other reasons, right? Not only data protection or operational reasons, but oftentimes our backup and disaster recovery programs are driven by compliance needs, right? For instance, Article 32 of the GDPR Act says that regular backups are essential, right? So if we operate in Europe, if we want to comply with GDPR, well, then we need regular backups. It doesn't matter what we think we need from an operational perspective. There are regulations in place that say we have to do it. And at the end of the day, it really doesn't matter why you are you are implementing data protection, right? It just matters that you need to implement it, and you have to think about how you're going to do that within the context of your business. If 451 put out some really interesting stats on this, so I'll go through this quickly, but it basically highlights this idea that data protection is not optional for many enterprise applications. For mission critical apps, 451 points out that the recovery time objective, basically how much downtime I'm willing to take, and the recovery point objective, basically how much data I'm willing to lose in the case of a disaster, are pretty rigorous for mission critical applications. About half of respondents say they need RTOs and RPOs of less than an hour. But importantly, even business critical and non-mission critical, or non-critical applications, excuse me, have RTOs and RPOs that are, in some cases less than an hour, and in other cases less than 2 hours, less than 4 or 5 hours. It doesn't have to be as quick, but we certainly need to be able to recover our applications and recover our data, even for those non-critical applications. Now, that's one thing, right? The fact that we need it is one thing, but when you look at actual recovery times, right, how well enterprises can actually meet those objectives, it turns out that they're struggling today, even for their traditional applications. The Uptime Institute has done some research on this, and they've indicated that 50% of applications are taking up to 4 hours to recover. 30% are taking over 5 hours, right? If that's our mission critical, our business critical application, then there's a gap between what we are trying to achieve, what we say our requirements are, and our ability to achieve that. Okay, so that's another interesting data point, but why does it matter? Well, 41% of outages cost businesses over $1 million, right? So the cost of failure in a data protection sense is very high. Okay, so we're here today to talk about data protection. Well, I've already got a data protection suite, a backup suite in my organization. Point taken, I'm just going to go ahead and use that. Well, I'm sorry to have to be the one to tell you this, but within the context of a Kubernetes environment, traditional backup and DR methods don't work for containers, right? And that's kind of a reality that enterprises, don't always expect. They expect that their enterprise data protection suite, their enterprise storage suite, can protect their Kubernetes applications just the way that they protect their VMware applications. But it turns out that that's not the case, and it's not the case for 3 reasons. One, traditional BCDR is machine focused, but containerized applications run across machines, right? So my data protection platform that's optimized to back up my VMs, right, is not going to be able to back up my distributed applications that are running in many containers across many hosts. The second reason is that traditional BCDR doesn't speak Kubernetes. So Kubernetes gives us these really powerful concepts like namespaces, where we can apply operational verbs, backup, encrypt, migrate, not just to a single container, not just to a single application, but to dozens or hundreds of applications at once. It really makes it easier to manage kind of clusters of applications at scale. But the underlying technologies that do the work of backing up and encrypting and migrating need to understand those concepts. And right now, if you take a traditional backup and recovery solution in your data center and you tell it to back up a Kubernetes namespace, it doesn't have the APIs to be able to target those particular concepts. And so what you end up doing is having to do things manually, having to do things machine by machine, which results in kind of very slow operations, high likelihood of error, or in some cases, just the inability to target applications at that level. And finally, traditional BCDR is centrally managed, but as you know, Kubernetes is all about self-service. It's about enabling development teams to deploy and run their own applications, right? So we can get out of the business of rogue IT, where dev teams say, you know what, I'm going to go do it myself, and they go off to Amazon and they spin up a cluster, and you have no idea what they're doing. Kubernetes gives us the ability to provide that cloud-like experience, that self-service experience, but still maintain control. Well, we can't couple that with a traditional BCDR program that continues to require central IT to intervene on behalf of every single application. The upshot of all of this is that without Kubernetes level data protection, your apps and your business are left exposed. This really simple example illustrates what I mean. So I've got two applications, a gray app and a blue app. What we can see is that each application is distributed. It's made of multiple containers, and those containers also run across multiple hosts. And that application is composed not just of data, but also of Kubernetes objects, configuration that's stored in YAML files. And if I want to back up my application, I want to be able to target, or I need to be able to target a particular application, app 1 or app 2, and not just the data, but also those Kubernetes objects, also that configuration. It's that group of objects that compose my application. And if I can't target that, then there's a heavy cost associated with my operations. We talked about slow, expensive ETL procedures as I kind of take tooling that was designed for a VM specific workload and try to apply it to containers. If I'm doing a lot of manual work, there could be possibility of losing something, and I end up losing some data. Slow recovery because I'm not optimized from an RTO perspective. Clearly no self-service. The list goes on and on. If I were to summarize this, I would really just point you to GigaOM, who recently said that without container granular backup options for Kubernetes, enterprises are exposed to data loss, downtime, and lost customer loyalty, right? The problem is real, and if you're running applications on Kubernetes, you have to think about that Kubernetes native data protection. This is what Portworx does for a living. We make a platform and solutions specifically targeted to enterprise use cases that enable kind of application granular Kubernetes native data protection technologies. We have something called PX Backup, something called PXDR, which are clearly targeted to those specific use cases. But before we get into that, I want to talk a little bit about, what is backup? What is DR? What's the difference? When would I use one versus the other? It turns out that the operational patterns are actually quite different between backup and DR. And there are even differences in the operational patterns for different types of backups based on the reasons that we're backing up. And the whole point of these next few slides is to start to have you think in terms of individual applications and individual application requirements, because what you're going to want is a platform that's capable of providing data protection consistent with those particular requirements in a particular way for a particular application, right? You don't want a one-size-fits-all solution for your data protection story when you're running on Kubernetes, because you're going to find that lacks the flexibility, and it's going to increase your recovery time, potentially increase the amount of data loss or your RPOs if you're not careful. So backup versus DR. Backup clearly is a regular and routine operation, right? We back up our app every day at 2 p.m. Whereas DR is exceptional and non-routine. Backup is often driven by compliance and not data protection, right? It's that GDPR example. I have to create a backup of this. It's not because I think I'm going to have to restore that backup. It's just I'm required to create that backup. DR, on the other hand, is most often driven by data protection needs, right? With backup, recovery is not always, but is often de-emphasized, right? Even my choice of term, I'm saying backup here, not backup and recovery. Oftentimes, just backing something up is enough, right? I don't have to think about recovery. Not always, but often that's the case. Whereas with DR, recovery is almost always critical, right? It's right there in the term, disaster recovery. We don't just call it disaster, call it disaster recovery. With backup, when we do need to restore, the recovery point is often not the latest version of the application. Whereas with DR, it almost always is the latest version of the application, right? In the backup use case, I might want to roll back to a known good version of my application before maybe a bug was created, or maybe a customer accidentally deleted, an important piece of data 2 weeks ago, and I want to go and recover that particular the application as it was before that error. DR almost always is the latest point. Now, what they have in common is that requirements differ by application. Not every application thinks about backup the same way. Not every application thinks about DR that way. So how can we start to map this to platform requirements or application requirements? Well, we can look at 3 different applications and what their requirements are around backup and disaster recovery. So for one, we could look at a CI/CD pipeline, which I'm saying is a medium to low criticality app, right? This isn't how our business makes money, but it's an important part of our development pipeline. There's really not a compliance impact. The revenue impact is low, and my RPO and my RTO objectives are relatively moderate. We could go up a level and say, okay, we've got a customer engagement application, right? Maybe it's a banking app that allows me to check my credit score, something like that. I'm going to call the criticality here medium, right? It's not how my business makes money, but it is how we engage with users. My RPO and my RTO are more aggressive. The compliance impact is high, I'm saying, because I've got user data in there, financial data, but the revenue impact is medium. It's mainly a reputation risk more than kind of a direct. I'm going to lose dollars for every hour that this application is down. Then you can have an application like transaction processing, my e-commerce shopping cart, where here the criticality is high. My RPO and my RTO are very aggressive, 0 data loss, 5-minute recovery. My compliance impact is high because, again, it's financial data, and my revenue impact is also high. We can take these types of applications and we can map them to data protection strategies or solutions based on those requirements. So if we take an application with that low compliance impact and low revenue impact, well, probably what we're going to need is periodic backups just in case, right? It's just slightly easier to recover from a backup than to build everything from scratch. But it doesn't have to be every hour I'm taking a backup. It might not even need to be every day. On the other hand, if I have an application with a low revenue impact but a high compliance impact, I'm gonna want regular backups, and I'm gonna want to be able to demonstrate that I'm going to want easy recovery, excuse me, and I'm going to want to demonstrate that I have, taken particular action. So, for instance, if I get a request from a regulator saying, hey, John Smith said that they requested you delete their data, and they suspect that you haven't, I want you to prove to us that you did delete his data when requested. Well, there you need to be able to very easily recover the application as it was after the data was deleted, to demonstrate that to the regulator, right? So recovery is extremely important in this case. It's not just a just in case, right? It's a core part of your compliance with prevailing regulations. If we keep going, we can say, okay, well, what if the revenue impact is high but the compliance impact is low? Here we're going to emphasize operational DR, making sure that we can recover quickly in the case of a disaster. And probably, so that's a full DR, 0 RPO type disaster recovery solution, right? Hot standby of our application. But we're probably going to want some static backups just in case as well, right? Now, if we have a high revenue impacting application with also a high compliance impact, here we're going to really need a full BCDR suite with backup for compliance reasons that we just talked about, the ability to demonstrate both that we are backing up and that we can recover applications, and that we can demonstrate that we've taken the required actions, as well as disaster recovery from an operational perspective. So we think about each app falling potentially into a different quadrant, then we can see that each app might have a different backup solution and a different disaster recovery solution. And all of these become layered on top of each other within our multi-tenant Kubernetes cluster, right? That's a new concept for enterprise backup and recovery, right? That different apps on the same server would have dramatically different requirements when it comes to data protection. So here, continue with my simplified example, I might have app one with a certain requirements around backup that I'm going to push to Amazon and restore in a different in a different environment. I may have another application that I want to put to Azure, push to Azure, and recover again to a third environment. The point being is that the ability to take individual applications running in a single Kubernetes cluster and push them somewhere else, right? Not just their data, but also their application configuration is really important. Same thing from a disaster recovery perspective. Different apps running in the same Kubernetes cluster need to be able to have different levels of disaster recovery. App one, in this case, might have that 0 RPO sub 2-minute RTO requirement. And in that case, I'm going to want to push it to another data center that has a very low round trip latency so that I can use something like synchronous replication. But for another application that doesn't have those same disaster recovery requirements, I might want to put it to another data center where either cost savings is primary to me, or geographic distance is primary to me, and I don't have a very strict RPO requirements, and so I can deal with a little bit more latency in terms of moving over those snapshots. The point being, I'm able to make those decisions on an app by app basis. Are customers actually giving this level of thought to their data protection on Kubernetes today? Yes, absolutely, 100%. And I argue that Kubernetes would not be where it is today if enterprises weren't doing this, because really what makes a technology transformative is when we can apply it broadly within an organization, right? VMware has virtualized 80 to 90% of the enterprise data center. That's why VMware is relevant. If VMware was only on 10 to 15% of the enterprise data center, then we wouldn't talk about it so much. For Kubernetes to go mainstream, we have to be able to run any application there. And what companies like RBC are demonstrating is that we can run these mission critical applications on Kubernetes if we can solve the data protection problem. And just really quickly, what RBC found is that they were getting a lot of benefits from Kubernetes, but they wanted to move more apps over. But what they found is that some of those apps had these really strict data protection requirements. In one particular case that we worked with them on, they had a requirement for 0 RPO failover, right? 0 data loss between 2 completely independent data centers. And with our PXDR product, we were able to solve those requirements. That application was able to come over to Kubernetes, and now they've increased the agility of their organization thanks to being able to run more apps on Kubernetes. And I think that's really a big success story. And if your organization isn't there yet, it's where your organization could be with a smart implementation of a data protection solution. So just to provide a little bit more detail about kind of some of the requirements for data protection on for Kubernetes-based applications, because I've said that traditional backup and recovery solutions aren't a good fit for Kubernetes, and I made an argument that it's all about application specificity, Kubernetes integration. But some people are still skeptical. Well, I've been using XYZ solution. I don't want to call any particular solution out. And I just don't understand why they couldn't do it for Kubernetes if they can do it for VMware, right? Well, there are basically 5 reasons that they can't, or at least that the solution is not optimal. The first one is container granularity. That machine-based backups are no longer sufficient for workloads when they're running on Kubernetes. Well, why is that? Well, if you think about a typical Kubernetes cluster, I've got many different pods that are running in that cluster. And oftentimes, groups of pods go together even though they don't go on the same machine. So here I have an example of a Cassandra database. That's a single database, but it's composed of 3 different nodes. Now, if I can only snapshot individual machines, node 1, node 2, node 3, then we can see there's a problem, right? My Cassandra data set is split over 3 nodes. But if I'm snapshotting individual nodes, then either I'm only capturing part of my data, or I'm capturing some data that I don't actually need, in this case, MySQL. The second point is that Kubernetes data protection solutions need to be Kubernetes namespace aware. That is, they must speak the language of Kubernetes. What do I mean by that? Well, a namespace within Kubernetes is really just an organizing principle where I can have many different applications that share a namespace, and that namespace could be by business unit. It could be by the part of the stack. Maybe it's front end apps run in a particular namespace and back end apps run in another namespace. It's just an arbitrary grouping of like applications, whatever like means in your particular concept. But a namespace can have hundreds or thousands of pods. And I might want to do things like migrate a namespace or back up a namespace as a group. And if I have hundreds of pods, I don't want to go in and take hundreds of individual actions. I want to be able to take a single action and apply it to hundreds of pods. That requires a sophisticated understanding of the Kubernetes APIs and the ability to provide a command and then do the underlying actions at each of the resources that fall within that grouping. And we've looked at some other data protection solutions where, because they lack that namespace awareness, you're looking at 8 commands per volume to do a backup of a particular application. And if you have hundreds of apps running in a particular namespace, that's hundreds of individual commands, which at best you can script. But if anybody has maintained one of those backup scripts, you know that they're very, very fragile, and there's always something to do, and that means you're going to be getting a lot of pages when things go wrong. The next point is application consistency. So when we're dealing with distributed applications, it's really important that we be able to take application consistent backups. So going back to our Cassandra example, if I snapshot Cassandra, I need to make sure that I've quiesced the database. I've flushed all of my writes on each of those individual pods down to disk. Then I snapshot. Then I release the lock on the database so that I continue writing data, right? That's the way that you take an application consistent snapshot of a distributed database. But that's going to be different for Cassandra, different for MySQL, different for Elasticsearch, Kafka, Couchbase, etc. Portworx, when we take backups, we understand the application that we're backing up and know the difference between a Cassandra and a MySQL, and snapshot in an application specific way, right? It's really important, even if you don't use Portworx, that you take backups in that way. Otherwise, you're going to end up with data corruption. The next point is that backing up a Kubernetes application isn't just about backing up data. It's also about backing up application configuration. Just the data is not enough. A Kubernetes application is composed of a volume, app configuration, and then Kubernetes objects. And there can be dozens of these Kubernetes objects, and that configuration specifies how containers communicate to each other. There are secrets there, there are service accounts. And if you don't have all of these objects as part of your backup, then your recovery times are going to be much, much greater. And you're going to struggle to meet those rigorous RTO examples for certain classes of enterprise applications, right? So it's important that all of your backups are at that application level, application granularity, which includes not just the data, but also the configuration and objects. Okay, so the last point, and then I want to show you a little bit about how PX Backup and PXDR solve some of these issues, is that your solution has to be optimized for a multi-cloud world, right? Different applications run in different architectures, different data centers, and you need to be able to mix and match your RPO and RTO objectives based on kind of your data center architecture. So if you operate across multiple geographies, then you need to be able to recover across multiple geographies. If you only operate on-prem, then maybe you operate in campus network where you need to be able to fail over between data centers all within a metropolitan area, and that has certain implications for recovery time, latency, etc. The point is, again, at an application level, you need to be able to to pick the backup and disaster recovery plan that makes sense for that particular application, given different network architectures and geographic requirements. Okay, so that's a high-level discussion, and you know, everything that I've just shared with you there is going to be applicable regardless of if you use Portworx or not, right? You can go to any other solution. You're still going to have to solve the problems that I've just highlighted. What Portworx does is we solve those problems for our customers, and we have a number of different solutions that target different use cases, right? So we have a solution that specifically targets the backup use case, which is different from the DR use case, which I shared before, how these things differ. So PX Backup, excuse me. So PX Backup is a point-and-click solution that allows you to back up any Kubernetes application, right? Its data, its application configuration, its Kubernetes objects from any environment and recover it to any other environment, right? It's highly optimized for that compliance-driven use case and the operational use case where recovery is really important. I can show you through some of the user interface what I mean by that. So here I'm showing the ability to easily choose the backup source, the destination, and what specifically I want to back up, right? Do I want to back up an individual pod? Do I want to back up all pods that match a particular tag? Or do I want to back up an entire namespace? Again, that level of granularity is critically important. I can see those backups in real time, right? If I have a compliance, I don't want to just set it and forget it, right? I want to understand, am I actually successfully backing up that application every day as is required? And sure, we're going to show you your backups that are in progress, any backups that have failed so that you can restart them, and any backups that have succeeded. Once my applications have been backed up, we can easily view those backups, including critical metadata like creation date, right? So if I need to go back and I need to restore a backup from January 1st, I need to easily be able to understand which of those backups happened on January 1st, right? Anybody who's tried to manage kind of large backup clusters in an S3 bucket understands that kind of when different objects are in an S3 bucket, it's really hard to understand what is what. PX Backup through the interface has made it really, really easy to understand which backup was taken when, what it's of, who created it, all of that important metadata. Then when it's time to restore, well, it's really just a point-and-click operation. What do I want to restore? Where do I want to restore it? And click a button. It really is that simple. It kind of takes the guesswork out of data protection for applications that require that really easy backup and recovery solution. So that's PX Backup. Now I want to talk a little bit about PXDR. PXDR, again, is a different use case. With backup, sometimes recovery is important, sometimes it's not. Sometimes we need a backup, or we want to recover the latest version of the application, sometimes we don't. With DR, recovery is always critical. Recovery is almost always the latest version of our application. And so the requirements or the way that we implement DR is different from the way that we implement backup. And so we've created a different solution for our customers. And what happens in practice is that many customers use both PX Backup and PXDR. It's not complexity for complexity's sake. It actually simplifies the backup operation and simplifies the DR operation to have a customized solution for each of those use cases. So with PXDR, what we have is basically the ability to create a version of our application at a standby site and recover our application at that standby site given a disaster. Now, based on what I said earlier, sometimes based on our RPO and RTO objectives, we might need to have those data centers with the active and the standby clusters very close together because we want synchronous replication of data across that metropolitan area so we can we can arrive at 0 RPO failover. In other cases, we want to have, an East Coast data center and a West Coast data center where synchronous replication doesn't make sense, but we still want to have maybe a low RTO, right? Low recovery time, even if we're okay dealing with a little bit more data loss given those latencies. PXDR offers 2 ways to solve that problem. One is using synchronous replication for Kubernetes across data centers in a campus network or in a metro area. And the second is synchronous replication for data centers across a wide area network. So in this case, this is my synchronous case where I have a single Portworx cluster that spans 2 distinct Kubernetes clusters, 2 distinct data centers. And if I lose one of my primary data center, I can fail my application over to the secondary data center. And Portworx has taken care to synchronously replicate every write from data center 1 to data center 2, and to move over all of the application configuration, all of the Kubernetes objects, so that in addition to an RPO of 0, I can have a very low RTO or recovery time objective, because recovering my application is basically, how long does it take me to spin on my pods? Not all data centers work that way, right? They're not all in a campus network. So we also have a second option, which is asynchronous replication. In this case, I'm going to recover my app, or I want to recover my application to a data center in another geography, right? East Coast to West Coast, Europe to Asia. And here, I'm going to take regular and incremental snapshots of my data in an application consistent manner, right? I talked about how Portworx can snapshot Cassandra or snapshot Kafka in an application consistent way, push those snapshots over to a secondary data center and recover in that secondary data center with the same low RTO, because again, even though I might have, say, a 15-minute RPO, right, because of my snapshots, all of my data is already there, all of my application configuration is already there, and I can simply recover my application by spinning up my pods. So that's all I have for you. I really appreciate the time you've given us today. If you want to try any of this, please go to portworx.com and click on the free trial button. We're offering a free 30-day free trial of Portworx Enterprise. You can try live in your own environment everything that I've just shared with you today. Please ping us if you have any questions. We're on Slack, we're on Twitter, we're on LinkedIn. You can always reach us. And we hope, regardless of the solution that you pick, that your Kubernetes journey is a fruitful one. And until next time, thank you very much. Bye.